Morning, all. Friday, March 25.
Zoom, zoom.
22 of a white day today. Lunch, Domino's pizza, toasted cheese sandwich with tomato soup, and stuffed grilled chicken salad. Mainline pork grilled chicken sandwich, oven roasted hot dog. Quinton Classic begins this afternoon, continuing the entire weekend. Boys Tennessee Western Invite, Park City Park. Today, and tomorrow. Dating varsity track in their season tomorrow at Park. All you're welcome to forward Friday every week during lunch. Mr. Lightbird Crew this week's topic is mandatory fix. All girls interested in golfing this spring. Mr. Lightbird today after school in the high school library. First practice is one day. Want to help with freshman impact? You're a sophomore, junior, senior. You know, Officer Gillette. If you want to help with the skit, you need to show up Tuesday or Thursday, 6 p.m. in the Commons. All freshmen take part in the Freshman Impact Program and scheduled for April 25. Seniors, reminder that the Build Dakota Scholarship deadline is March 31, next Thursday. If you're attending any of the technical schools, Mitchell Tech, Lake Area Tech, South, East Tech, or Western Dakota Tech in Rapid City, you're eligible for this scholarship and all the programs that go with that. It is a basically free education for the 2 years that it takes to complete the program. You do have to be admitted to the technical college in order to be eligible. Stop in the guidance office. Visit with Mrs. Murphy if you're interested in the Build Dakota Scholarship. All please stand for the pledge. To the flag.
Into the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right.
We're still going. Okay. I know I had one or two ask about it. If there's anyone who knows they're going to be gone next week, we start Chapter 4 on Tuesday. Chapter 4 packets, top right corner of the shelves up there. That one's going to be like the next 3 weeks. That's the big one. That's the one you have to know to move on to trig. If we ever got a kid who's kind of on the border, you know, somewhere below 80 in PreCalc, and we're just trying to figure out about whether they really should go on a trig or not, the thing we look at is Chapter 4. Like, what happens when you have your C, you got your 75 in PreCalc, you can theoretically move on to trig, but then we look and your tests from Chapter 4 were all, you know, dismal. Maybe not a good idea. Okay, so that's the big one. It's not anything crazy difficult, it's just you got to work in terms of pi, you have to have simplified fractions, you're going to graph things. That's it. All good? Okay, we've done them enough times now. Step 1, take log of both sides. If I take the log of 3 to a thing, that thing comes out front as an exponent, or as a coefficient. If I take the log of a thing, its exponent comes out front as a coefficient. We disturb it, making sure to write it carefully. 6 log 3 x's minus 3 log 3. We disturb it, getting 4 log 2 minus 4 log 2 x. There we go. I want all of my x stuff on one side, not x stuff on the other. So add this one over here. And I'll put not x stuff on the other side. And if I have this much x plus this much x, then altogether I have 6 log 3 plus 4 log 2 x. And I'll divide by it. Now if you add that, great. If you want to flex, what's that? 27 to the 4th 16, 270, 6, 120, 390, 72, 404? Or did I just 404 error? I don't know, Finn, you're the one who wanted to do this all the time.
The bottom one is 2 log 27 over 4.
Whatever 16 by 27 is. Log of thing. Or you could have log of mutter over log of mutter. Okay, so whichever one of those you had, it says, in simplest terms and nearest thousandth, to make sure that we're all on the same page no matter which way we simplified it, about how much? 648? Yay, nay? Bobbles? Okay. All right. So the process has been, can you put them as coefficients? Can you distribute correctly? Can you combine like terms correctly? Can you divide correctly? Did you do a whoopsie? Like left one of those as a negative. I've seen kids, as they're moving things around, maybe they just accidentally swap this and call it 3 log 6. Or maybe that's the way they typed it in their calculator. Okay, so that 1 is there for the whoopsie. Anything? Okay. It's on the other page. You, go over there. Anything from the homework? Anywhere from the homework? No? Even the word problem? You notice it was different because now it asks for continuous. So now you just have to use noect instead. For those of you that did it. Okay. Test is Monday. I haven't decided. Keep in mind that this week, these 5 days have been section 3.2 through 3.5, so almost the entirety of chapter 3. So expect the whole lot of logs and exponents. Everything is fair game for your quiz on Monday. I would expect graph analyzing transformations of a log, an expand condense problem, probably 2 equations, one of today where you have to choose an appropriate model. I'm not sure about the 5th one or the 6th one. So the title says it. You've done it enough times. You shouldn't have done it a whole bunch in Algebra 2, but we've done it plenty in here. Blah, 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 regression. Y'all remember how to do regression? Step 1, how do you make a scatter plot in your calculator? Stat, edit, dump stuff. Okay, I've got data. I want to see the scatter plot so I know what kind of model I should be choosing. How do you get the scatter plot? Turn the stat plot on, second y equals. Okay, uh-oh, it doesn't show my data. Zoom to your stats. I see a curve that goes this way. Well, that looks like a logarithm. How do I get any type of regression model? Stat calculate, and that's all the different stuff that we can do in a calculator. So you've done this with a bunch of different models. You've done it with quadratics, cubics, quartics. You've done it with power functions. You've done it with exponential and log before. Now it's just we jam it all into one spot and say, all right, which one do you use? And you might have to pick from the list something that we haven't done before, like a logarithmic, or choose the difference between a logarithmic and a power function. Which one is more appropriate? Okay. So calculator, plug and chug today. It's going to be fairly quick. You have Boy, is that outdated. Because the population of Mesa, Arizona kept going up because of old people, but then in 2020, old people died. Anyway. Yep, million people dead. That's funny. So if I want to have all that data in my calculator, I probably don't want to start at 1900. Right? If I start at 1900, that means I'm going to have a y-intercept value back at the year 0. And it's going to say that there were negative 19.8 thousand people in Mesa, Arizona in the year 0. And that just doesn't make sense. So the first thing that we always do with these is we define our variables. If this is population times 1,000, I'm going to define x as what? Years since. You want to just start at 1900? Okay, so I'd say years since 1900. Now I'm putting it up here in coordinate form like this because maybe sometimes we're a little iffy on what the x and y actually mean when we're answering these questions. But also, I've been doing it like this with my algebra half all semester. Okay, for us, we would probably just off to the side say x is years since 1900. And that'd be good enough. But if having the coordinate helps you to answer questions in context of a word problem, not a bad idea. Okay, I got a bunch of data. Stat, edit, start typing. Okay, stat, edit, race you. Okay, we'll double check our data, make sure it's right. Sometimes Frank doesn't like decimals or zeros. Yeah? Okay. Everyone there? Supposed to have the fastest thumbs of any generation. Spend half your day on a device of some kind. I suppose you don't even communicate with words anymore. You just take pictures and it all goes on Snapchat. Huh? 288? I was trying to read off of my tiny little screen there. Because I've got the stream software up, so it's like a mini window of this. All right, so we got to back that up. 288, that's good because my model would have been just a tiny bit different than yours. Okay, thank you for the check. Okay, we have that now. I know that the problem says exponential regression, but to confirm that it's probably going to be exponential regression, I should see my scatter plot. So I see that behavior of an exponential function. We said our scatter plot was second above y equals stat plot. Turn your plot one on. Make sure it's a scatter plot, not any of those other types. Make sure your lists are correct. What if I need to change it? What if I had the same years, but then the next table was, I don't know, like Daytona? Now what? How could I switch this to stay years and this over to the data from list 3? It's just down there, right? Second, 3. Okay, I am going to change that. It's always a little easier to see if I do, right? Magenta. Okay, and then I go to graph, and that's all I see. Oh yeah, we got that from before. Oh yeah, that's right. The powers was showing the how do you get all the different powers on there if you don't know them. Maybe we should get rid of those. Okay, that's better. We said if we can't see our data, option 1 is I manually change it. I went from 0 out to at least 100, and I want to go further. I went from nearly 0 out to about 400, and it's going to go further at an exponential rate. I could go to my window and say, well, go from 0 to, let's go 150. That'd be the year 2050. We'd be able to do a little extrapolation. Maybe go by tens. From 0 to, well, it goes to 400, and then it's going to keep going at an exponential rate. How high do you think we should go? 500, 600? I like 600 because it's exponential. It's going to get big. Go by, I don't know, 50s. Graphify. And I can see everything. Okay? It does look like an exponential curve, so it makes sense to use an exponential model. We said those are stat. Over to calculate. Everything on this list is all the stuff you can do with your data. We specifically want exponential. Be careful, the difference between exponential and power. Remember, exponential versus power. A power function is x to the n. An exponential function is n to the x. Depends where your variable is. So exponential regression, all that stuff. How do we store it again? Okay, if you're on the TI-83s, on the older ones, you got to go variables, the y's, the function, y1. If you're on 84 and better, you can alpha trace, just brings up shortcut menu. Okay, either one of those, calculate. Doop. Look at what it says. That's what you're going to have to type if you're on the 83s. Remember, 83 is the emulator that is on your laptop. So when you say, I didn't have a calculator, I couldn't do my homework, I laugh at you and say, ah, yeah, you did. Okay. I got a model. Does it match yours? Okay. So, blah, 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 blah. Y equals 0.690 times 1.067 to the x. And I stored it so that it's going to be easy to answer the question. Use your model to estimate the population in the year 2020, assuming the world didn't go to hell. What do I put in and where? 120 for x, because again, we're talking about years since 1900 as my x variable. So I could either, remember, I made this big enough. I could just trace it. Don't want to trace the plot, that won't work. I could trace my function out to 120, and it'll tell me. I could make my table over to an ask feature, so I can just start asking it stuff, and it'll tell me, hey, in the year 120. What is it? Oh, maybe a note for this. These cells will not change width. So they will cut off the answer in this display. And a lot of times I'll even go to scientific notation. If you just highlight the cell, it tells you the whole thing. Okay? What is this, though? What is this number? Okay, this was about thousands in the city. So I need to take that decimal and move it. When they ask, what's the population going to be? I'm going to say it's about 1,675,940 people, most of them with gray hair. Who's got the snowbird grandparents? Head down to Arizona or Florida every winter. No? Okay. So I did my undergrad in Arizona, and y'all, you drive around the Phoenix metro area, and if you have North Dakota, South Dakota, Minnesota license plates, there's like this bubble around your vehicle on the freeway where people just don't want to be anywhere near you because old people, particularly from the Midwest, don't know how to drive in a larger city, and they cause accidents. I kept the North Dakota plates on my truck as long as I could because people would just leave me alone. It was great. So, blah, 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 blah. Y'all know how to do it. Like, I don't want to belabor this if you know how to do the thing. I'd rather just do one of each if you are confident. Show me thumbs. Can you do exponential regression? Okay. Cross the bottom one out. Logarithmic regression. So, blah, 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 blah. Dump everything in. And now we're going to make a logarithmic model. So first, let's get all of our data in. How do we want to state our data? Years since what? Since 1990? 900? What? Or 95? Okay. Everyone go with years since 1995. And race you. Make this a little bit bigger so we don't get called out again. Okay. Calculator. Okay. Hey, how do I clear my lists if I don't want to just reset the entire calculator? Right by memory is just clear all lists. I could also, not second, I could also stat, edit, be very careful. I would hit clear, not delete. If you delete, you will actually delete the list. Someone found on Google how to get it back last semester, but I've never used it because it's annoying. So just make sure if you're trying to clear the lists, you clear, not delete. Otherwise, your list goes bye-bye. Okay? So, dump stuff in. Oh, those are big numbers. 9, 6, 7, 3, 6, 1, 0, 3, 7, 1, 0. And we got your data in? Okay. Get this guy out of here. Nice thing about clearing your lists and then just reusing them is the stat plot should still be on. It should still already plot those statistics. They're just in a different place now. When I go here, I already saw some of you scrunch eyebrows. Why are you doing this? Okay, because some of you have already pressed the buttons, you know why we did this. If I try to calculate, first of all, it says logarithmic regression. Scroll on down. What do you think we're using? We'll use natural log. Okay. Now, we don't want logistic. That does happen later. We are doing that in a little bit here. Okay, logistic is a different type of regression. Just because it has log in it doesn't mean that's logarithmic regression. Why would they only have natural log regression on here and not log-based regression? What's different with a ln versus a log-based something? E. And I would use continuous. It makes sense that if I want to make a model, I want my model to fit a continuous level of growth or decay. Because what happens when I plug in my data and then I choose my x? Is it only going to be at discrete intervals, or can I pick whatever the crap I want along there? Okay, so that's why we have continuous. So I'm going to do logarithmic regression. Now I had the 0 through 10 in my list 3. So I'm going to change this to list 3. I go to store. I poke the buttons and it says, you can't do that. Read what it says. This is an example. You entered a value that's not allowed in that function. 0. Right? We tried to do a logarithmic regression and our first data point was 0 something. Thou shalt not take log of a non-positive. So I want you to put a note next to this that with logarithmic regression, you cannot have 0 as an x value. So instead of years since 1995, how about we back it up to 1990? Not far. You could go to 1900 if that's your jam. So you could put in 95, 97, 98, 100, 102, 104, 105. That works. I'm just going to back it up a little bit. I'm just going to go back to 1990. Because now I don't have 0 as a value. Also, check out the go-to. Go-to. It says you tried to do a logarithmic regression and something here is dumb. In this case, my list 3 was dumb because if I stat edit, I tried to take the logarithm of 0. So let's get that out of there. And instead, I'm going to have 5, 7, 8, 10, 12, 14, 15, because now I'm going years since 1990. Stat calculate, still logarithmic regression. Switch that back to L1. Store it so I don't have to retype things later. Also means I won't have my round-off error. Yay or nay? I'm seeing a couple of bobbles. Okay. So we have y is a plus bln of x. So 38,428.963 plus 35,000.168 ln of x. Which is kind of cute that they just have that as a and k value. Yay, I got a model. My stat plot should still be on because all I did was clear out the list. So if I zoom to my stats again, you see that logarithmic curve where it starts to taper off. Now this window goes from, what are these x's? 4 and 16, what does that mean? In context of this problem. Years what? Since 1990. So my table, or my window only goes from 1994 to 2016. I don't only want to go to 2016. Use your model to predict when it's going to hit 150,000. I need to instead go from maybe 0 to, I don't know, how far past 1990 do you think this is going to happen? Because it tapers off. Probably not just 2020. Probably not even 2030. What?
That's supposed to be 38,428.
I just miss a number in there? Talking and writing at the same time is difficult. Yes, it's a brownie point. I'm at least going to do 2050. At least. Okay, I'll try that again. Well, that was dumb. Okay. Window, maybe we need to go a lot bigger. Oh yeah, because I want to go to at least 150,000, right? So maybe 160,000. Better. We're getting warmer. I just want to see where it starts flatlining. Ha! I win. Okay, 2 ways to do this. Option 1. They want to know when this hits 150,000. We've been doing this for a long time. 150,000 people is X or Y. So what did we do to solve that when we're doing all this calculator junk? Go put in Y2, 150K, and I'll just go find my intersection. Calculate intersection between you and you. Okay. What does that mean? 24 years from 1990. So in the year 2014. Okay. How could I do that a different way now that I know how to solve logarithms? Okay. I could put 150, 1, 2, 3 right here. Say 150, 1, 2, 3, divided by that 38,428.963 is a thing. I was supposed to subtract that, wasn't I? Subtract. Divide by whatever's in front of it, 35,123.168. I now have 3 point blah, blah, blah equals ln of x. If I have the ln of x equals blah, 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 what do I do? E to that power. So I'll say second e to the, my answer, 24 and change. Now compare this to what we got from the graph. It's pretty close. It's not dead on. Why not? I rounded my answer off when I started typing over here. I went to the thousands. And this is why I have that thousandths policy, is because if I go out to the thousandth place value, it's still pretty accurate. But when you back it up to the hundredths, starts getting a little iffy. You're going to have enough round off error to matter. You back it up to the tenths, now it's just gross. Go to the whole number, what are you doing with your life? Okay? So, I hope you have the note written on there. If you ever do logarithmic regression, don't you dare start with a 0 in your x table, because it'll just tell you you can't do that. So just start in such a way that you don't have 0 at the beginning. Okay? Blah, 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 I can press buttons. New note, cross out the bottom. In case you haven't figured it out, today's going to go fast. Okay, logistic. Logistic is something that's new. For us, we're not going to manually deal with them. It is just a button. And logistic is one of the few ways that you can actually break your calculator, because the calculation on it takes so long. We're going to see that little yellow circle of death up in the corner. Remember, every time you do that, it starts thinking. If it's yellow, it's thinking. Don't touch it. Because in the middle of a test, it would really suck if I was over here saying, do it, do it. Why aren't you doing it yet? Do it, do it. And then start poking her. In the middle of a test. You can't think when someone's doing that to you. Your calculator is trying to think. Be kind. Because as soon as that little yellow circle goes white, now you have frozen your calculator. And it can happen with logistic regression. So just be patient. All right? Be patient. It takes a while to think. Do it! Oh God, someone's going to do that now on Monday. Just like at the person next to him. Do it! Okay. Logistic is, please don't do that. Logistic is this big ugly formula here. Okay? What does it look like? Like, describe the graph. Exactly. Okay? You're all at the very least sophomores or juniors. So you've heard the word homeostasis, right? It's a body system or an environment's tendency to balance itself. Okay? We have too many spiders. The spiders will come in the house for food. Well, we have a plague of grasshoppers. The spiders stay outside because it's a banquet out there. As soon as the grasshoppers die off, the balance, right? The whole, like, there's too many rabbits, so predators come in. You know, wolves, bobcats, mountain lions, foxes, whatever it is. But then, after the rabbits die off and the food supply is gone, don't the predators disappear as well because there's no resources? Okay? Things can grow at an exponential rate, but it's not feasible for them to grow at an exponential rate forever. The example was, what if I decided I'm only going to give you one problem of homework? And then every day for the rest of just March, I'm going to double it. And then it's 2, and then it's 4, and then it's 8, and then it's 16, and then it's 32, and then it's 64, and then it's 128, and I don't even know if there's that many problems in the section. I guess I'm just going to have to go find some old books and add on. It starts getting unreasonable, right? It just doesn't make sense anymore. So that's where logistic comes in. It takes exponential growth and then understands that there will be a natural limit to it, which is also why it's using E, natural limit to continuous growth. And C, it says it over here, but you need to write, C is the limit of the function. Meaning it's never going to go past C. Ever. Like, it just will not cross that boundary. Okay? It's like if you were doing a poll and you were voting, there's never going to be 0 people voting for this category, because there's always going to be that one kid who's like, memes, and just picks that one option, right? Or someone who's just a conspiracy nut and was like, of course I should have Mariah be the class president because she promised that she was going to give me my parking spot up front. I have to vote for her, even though she has no authority to do that. Don't do that. Okay? There's always going to be some sort of natural limit. So, blah, blah, blah. Okay, you're all in cross-curricular courses here. You're going to do a population of yeast in a culture. Have you ever done the Petri dish thing? You put the swabs on like the calculators, on the doors, on the toilet seat, on your phone, and then you bake them over the weekend and see how gross it is. Okay? Why would it make sense that I should do logistic growth for this? Right? That Petri dish is only so big. There's only so much food. There's only so much resource. And they will consume it and they will run out of room. That's why a healthy forest, how many of you go hiking out in the hills? A healthy forest will have very little undergrowth because all the trees are tall enough that nothing at the underlevel can survive. Y'all remember when the Crow Peak was on fire a couple years ago? They just let it go because it was only burning out the undergrowth and the trees were going to survive. It was actually healthy to do that. So there's only so much resource. I should go to logistic. Just like before. Uh-oh, I have to start completely over. How do I reset my calculator? Okay, second plus 7, enter 2. We've said it enough times. I said that'd be like a little mantra. Okay, go ahead, dump all that stuff in. Who's going to go next level and get that as a tattoo?
Oh, for sure.
Okay, stat edit. Dump it all in.
It's gonna be my just like all math books. Second plus 7, 2. Go to Nicole. Carl, if you know you. I remember you said something last time. He's like, okay, who's gonna get that tattoo? Like you actually said that. Which time? That happened so many times. It was the first time.
2. Frank, you stupid son of... Only way to make him do what he's supposed to. But that's how I win, and you're just mad because you're not good. Cinder, Killer Instinct, Super Nintendo. Forward smash, medium punch, over and over and over and over, and it's an infinite combo.
Oh, what don't you understand? That's what I understand. We're talking about something, right? I don't know what it is.
Ah, crap, I missed one. 10, 19, 31, 45, 68, 120, 172, 255, 353, 445, 512, 561, 597, 629, 641, 653, 654. There we go. Okay. So logistic regression, again, it's just in that list. Stat plot, plot one on. I like my green. Stat. Huh. Okay, logistic regression. I said it takes a while. List 1, list 2, I want to store it because I don't want to have to do this again. All right. Let's do this, Frank. So how about that weather? What y'all doing this weekend? I said, logistic takes a while. If you start hitting buttons, if you start hitting enter, 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 you're just gonna have to do it again. You know you lost the crowd when they start getting loud. The audience stopped caring. Oh, there we go. Okay. That was almost a full minute. Okay. So I write out y is a boot. 131, 178 over. Make sure you write it correctly. 1 plus. That was C. Okay. So you write out your whole honking equation there. Good thing I stored it so I don't have to fight with this. What's up?
Never mind, I think mine's just wrong.
Oh. So I stored it. Use your model to predict the limit to the growth. So when is it going to stop growing? When is there no more resources? When we hit about 661 and change. Remember, C is the limit to the growth. Now, if I zoom to those stats again, you see that curve. Okay. We actually see it very well because of how many data points there were. So, if I were to extend that window out, if I kept going and going and going and going, oh, 50. You see how it just cuts off. This far, no farther.
Does it 661 though? Or is it like
It will hit 661 itself because the limit is 661 and change.
but it won't have the change?
So at 661.5642, it's there, but it's never going to go further. It's just going to skirt along that asymptote. This is a horizontal asymptote. Okay? So, blah, 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 new button. Okay. Again, cross it out. If you know how to do regression, which you should by now, the catch to it is deciding the appropriate model. Just like when we did our polynomials. When we did polynomials, remember the spaghetti monster? Do linear, quadratic, cubic, quartic, find which one's the best. Do you remember what the rule was? How do I pick the most appropriate model?
Does that the best fit inside of the data and then
Inside and outside, right? If it's inside the data, you're going to choose whatever has the best R coefficient. If it's outside the data, you're going to choose whichever one makes the most sense. Well, in this case, because we have, see, the difference between them, an R coefficient of 0.94, 94% fit, is actually not bad. But then you go and look at the graph, you're like, no, not even close. If I try to do logarithmic, it's not even going in the right direction, which is why it has a 58% fit. Now that it's getting warm out, I see some students rolling around with 58% fit. Okay? So you're going to choose which type of model makes the most sense. I should probably not do linear, quadratic, or logarithmic for this based on its scatter plot. So step one is always to look at the scatter plot. Then you're going to pick the models that make the most sense for that type of graph. In this case, power regression, exponential regression, and logistic make the most sense. You see how power regression ended up as a 94% versus exponential was 99? I would already cut that out. I'm down to exponential and logistic. What would be the difference between exponential and logistic about when I chose it? When would I choose this versus I would choose this? Okay, logistic is going to be something that is a natural limitation, a real world limitation. Say I'm talking about the cost of gas. Okay, it's going up because transportation issues, plastic shortage. You know that plastic is created for petroleum products? So when there's increasing gas prices, that's also going to increase a shortage in plastics, which is pretty much everything you use in life. Okay, what happens when someone decides to be a giant dictator and invades a country? Well, now all of a sudden we have less gas and the price goes up and the price goes up and the price goes up. Will it go up forever? Will we eventually have $130 per gallon? No, because it's not feasible. It's not feasible. At a certain point, you have governmental administration step in and say, this is a necessity for life, we will cap it. Y'all know what the Federal Reserve is? You heard about that in the news? Okay, interest rates right now are the lowest they've been for decades because everything was terrifying for a few years. They said, all right, let's keep people spending money even though they don't have it anymore. Let's keep people spending money by bringing all of our interest rates down. Well, now people are trying to spend money for stuff that isn't there, so they need to bring the interest rate up to tell everyone, all right, slow down now. Okay, slow down now. Rein that back in a little bit so the prices won't be so bad. This natural limit is going to happen in a real world context. This, well, if I was trying to pick what's going to happen when here, well, yeah, then I'm going to choose my exponential model. But if I have to go past a certain point, if it's not reasonable or feasible for something to increase exponentially like that, then I'll choose logistic. And I'll tell you what, 99% of the time, if there's a word problem with it, we're probably going logistic. Just because it doesn't make sense for, I don't know, the cost of the new DLC for Fortnite to be $3,000. Like it just, at a certain point, it just doesn't make sense anymore. So, choose a regression. Step one to choosing a regression. Dump stuff in calculator, get your stat plot. Okay? This is the distance a seismic wave can travel from an earthquake's epicenter. So how far away from the earthquake do you feel it?
Can you include zero in logistic regression?
Can I who what?
Can you include zero in logistic regression?
No. Because it's it linearizes and then delinearizes data using E and log. So no. Thankfully, this starts at 1. Hi. Okay, bye-bye. Second plus 4. Enter. Clear lists. Stat. Edit. 1, 2. Okay, Finn brings up a good point here. If I might have to do a logarithmic graph out of this, and I don't know before I even start, I should just make sure that I do not have 0 in my x values. Anytime it says choose a regression, choose a model, just don't have 0, just in case. 400, 800, 2500, 3900, 6250, 8400, 10, 1, 2, 3. Okay, so I got my data in. If I'm going to choose an appropriate model, I want to see my scatter plot. So I make sure plot 1 is on. I zoom into my statistics. Oh, it still has last time's graph in there. Oops. Clear. Okay. What do you notice about it? Could a line fit my data? It's got a little bit of a curve to it. It wouldn't fit it well, but actually wouldn't be terrible. Could a parabola fit this data? You see the curve where you could have a big base there for a vertex? Could it be exponential? Could it be power? All of those curve upward. Okay? Quadratic, exponential, power functions, they all curve upward. Logistic curves upward and then tails off. It could be all of those. Could it be logarithmic? It's not curving the right way. Remember, logarithmic graphs curve this way. Concave versus convex. Remember those terms? Physical science. Okay, concave is caved in, convex is the other way. So I have to try to find a bunch of stuff, and I'm going to start comparing coefficients. Also, travel time and distance. I should probably go further because I'm eventually going to do some form of extrapolation with this. So maybe I'll change my window first. I'm going to say from 0 minutes to, I don't know, I feel it a half hour later. It's pretty big. From 0, distance of 0, you're right on the epicenter, to how far away could we go? Other side of the planet? Anyone know what the circumference of the Earth is? What is the circumference of the Earth? Your generation has everything. We used to have to go to the place with the books to look that up. In the Dewey Decimal System, in a card catalog. Just Google it. Okay, thank you. So if 24,000 miles is the entire circumference, Does it make sense to go to maybe the other side of the planet? And I don't know if it would keep going. Would it like wrap around? Well, okay, so let's just go 24,000 and say it goes all the way back to where we started. It hits you again. And then look at the graph. Boom! Ow. I might. Okay, so then you see that curve. I'm going to get, I'm going to have to compare R coefficients. It's not going to give me R coefficients right now. How do I turn them back on? Remember? No one has notes from maybe in chapter 2 when we did this. Maybe that was the lesson video that a chunk of you didn't do. Okay. If you're on TI-84, under mode, you can just turn stack diagnostics on. Okay. You just turn stat diagnostics on. If you are not, you can second down to 0 is the catalog. The catalog is everything that your calculator will do. All of it. Every function, every operation. I'm going to skip down to, right above my reciprocal button is D. I'm going to skip down to the D's. And same thing, turn my diagnostics on. Okay. So whether I go through the catalog, old school, or I got a newer calculator where I can just go to my settings. All right, stat, calculate. I'm going to make a line. And say, Y1 is 776.695 x plus minus 940.678. Correlation coefficient of 97.6% or 0.7%. Remember, use R squared, not regular R. You'll do more with it in stats. I'm also going to try a quadratic. Alpha trace, I'll put in Y2. This is no different than what we did with our polynomials. And say Y2 is 36,623x squared plus 264.048x plus 147, just plain old 147, with a 99.8% coefficient. So we're already seeing very, very good fits. Stat, calculate. What else did we want? We wanted exponential and power. Exponential, I'll put into Y3. .483, 612. 1.284 to the x. Uh-oh. 94.0%. Turns out that exponential didn't fit very well. I mean, it fit decent, it just not as well as my parabola, not even as well as my line. Go again. Stat. Calculate. We also wanted a power function. Well, first of all, I got to make sure my colors are right. Green and then purple, okay. Power function. Putting in Y4. 361, 828, x to the 1.251, R coefficient of 99.6%. So I've got all of these things that seem to be making a lot of sense. I want you to look at the logistic, though. What's going to be different about that? Mine takes at least a minute. You have time to catch up. You better have all 5 of those models on your screen. You got to be able to choose the right one. We did linear, quadratic, exponential, power, and now logistic. Oh, 15,841.492 over 1 plus 25.111 e to the negative 0.284 x. But if you got your logistic model, what do you notice about that screen? There's no R coefficients, which might be something handy to write down, that a logistic model will not have a correlation coefficient. And it's because it assumes that there is a limit when there might not be. So I can't say that it has a particular fit because I'm making an assumption. Okay, so we've got 5 different models. Graphify, we got a line, we got a parabola, we have power and exponential, and then logistic. And I'm actually going to, second stat plot, I'm changing my color on this so I can actually see where those data points are. What's a color that wasn't on there?
Red.
Orange. Orange wasn't on there, right? Okay. So the line fits not bad. The parabola fits better. You see how the power function actually doesn't fit very good? It bows out of the data. I should probably throw that one away. Green is my exponential, and that fit really well. Logistic fits almost perfect and then tapers off. Go back to the context of the problem. What are we talking about? Okay. How far away can I feel that earthquake? And, oh, get back here. I said get back here. All right. I want you to look at the logistic model. What was the limit to how far that thing's going to travel? 15,000 and change miles. You said the circumference of the Earth was 24,000, so would it seem reasonable that on the Earth I can have an earthquake happen here and it wraps around, but on the backside of the Earth it's going to have waves going this way and waves going this way hitting each other on the backside of the Earth? You know anything about harmonic reinforcement, harmonic dampening? Ever heard anything like that in your science classes? Okay, how about on a trampoline? You're bouncing and your friend's bouncing, but then you get kind of out of sync and one of you ends up kind of flopping. Or you bounce at just the right way that it kind of makes it into a brick and you both just kind of stop, right? That's what's going to happen on the backside of the Earth. These waves are going to very lightly, because it's been a big distance, they're going to kind of crash into each other and they're going to start to dissipate each other. You ever seen that in a lake, a pond, a pool, where you drop something in here, you drop something in here, and the ripples hit each other and then just kind of becomes a mess and settles in the middle as just a general chop? Okay, that's what's going to happen here. The logistic model makes sense if you know that. If you didn't know that, which model would seem most reasonable? Okay, best fit. Okay, so I would choose the quadratic model unless I have to go past a certain point to extrapolate. So determine how far from the epicenter will the wave be felt at 8.5 minutes. Well, that's within my data. It's within my data. I will definitely use the quadratic because it had the best fit within the data. If you still have your table set over to ask, nice thing about that is it gives you all of your models up there. So if I said at 8.5 minutes, it'll give me the answer for all of them. See how far that power model was just out of whack with the other ones? Even the logistic one didn't kind of fit with Y 1, 2, and 4. So I will choose about 5,037 miles away. It's more about, can you understand what's reasonable? You know how to press the buttons. We've done it enough times. This is just practice with the buttons and saying, do I understand what it means? Can I use the information? Don't worry about the next one. Linearizing data. I'm going to give you the key to how your calculator does all this regression. How is it able to do a quadratic model and a quartic model and a logarithmic model and a power model? It linearizes the data. So if I have something that fits a quadratic model, what's the opposite of x squared? It takes all of my data and it square roots all of that stuff. And do you remember there was a formula for line of best fit all the way back in algebra half? Like you did trend lines, right? Try to go through the middle of your data, pick 2 points on the line, make the equation from these 2 points. But there was a formula that would actually find the perpendicular distance between all of those points. There is a formula that is done by distance formula and geometry to make a line of best fit. Your calculator, when you hit log regression enter and that wheel starts spinning, what it's doing is, what's the opposite of log? Exponents. It's using the definition and taking all of your data and exponenting them. If I have exponential data, it logs them. And then it does the line formula to them. And then it puts them back where they were. That's just what your calculator's doing. Why would we do that manually? Why would I have you linearize data if that's just what your calculator is doing anyway? Cross out the last 3 pages. That's what it's doing. If it's a cubic model, it does cube root of all of your y's, does the linear formula, and then cubes them back into place. That's just what the calculator is doing. Why would I make you do what the calculator is doing? It's doing it for you. We already know how to do it. Okay? What I will do with these handful of minutes that we have at the end, chapter 4. The beginning of chapter 4 assumes that you know certain things because you all went through geometry. You remember? Do you remember basic right triangle trig? From any angle, opposite, adjacent, hypotenuse. How do I know which is which? Hypotenuse is always across from the 90, and it's always the longest side because it's across from the 90 angle. You remember there's angle proportionality theorem that says biggest angle is across from biggest side, smallest angle across from smallest side. I can't have an angle bigger than 90. Why not? Adds up to 180. I can't have 90 plus 95 plus something. That's too much. Opposite, the way that I always remembered it was it's the stick you put in the gator's mouth so you don't get eaten. How many times have you seen that in an action movie or something? I saw Arnold Schwarzenegger do that in Eraser. Like jammed a chair leg in the croc's mouth so that it didn't eat his leg. Okay?
How do you tell between opposite and adjacent if you're...
Because opposite is always straight across from that angle.
I mean when you're at the 90-degree angle.
When you're at the 90-degree angle, you don't use any of these because these apply to the acute angles of a 90-degree triangle. 90 is special, and we're going to learn all about that. So what is this SOHCAHTOA business? You remember? Sine is opposite over hypotenuse. What else? Cosine is adjacent over hypotenuse. Okay. I see like 2 or 3 of you are catching on. Son of a... All right. Good thing that we already finished. Okay. Y'all remember where Philly Ted's was?